Hello dear students, this is grade 11 mathematics lesson on unit 8 vectors and transformation of the plane. This chapter is designed for natural science students only. So today we focus on vectors. So after revising this lesson, you are expected to find dot product of two vectors and find the angle between two vectors, and you are also expected to find some difference of two vectors including their magnitude. So now let's see the lesson one by one. Let's see about vectors starting from lower grade. As you know, vectors are quantities that have both magnitude and direction, and it is represented by arrow. And as you can see from this arrow, this vector has initial point. This is the initial point of the vector. Initial point, and it has also terminal point. Initial and terminal point, and this length is a magnitude. Of the vector. This is the magnitude. And this arrowhead indicates the direction of the vector. Now, if the initial point of a vector is at A, where A is the coordinate of A, x1, y1, and its terminal point is at P, x2, y2, then the vector AB is given by, simply take the difference of the coordinate of terminal point and initial point. So the terminal point here, it is x2 minus x1, this y2 minus y1. So the vector AB, it is given by this form, and I can write this using a unit vector representation. Look, this one. If we have a vector v whose coordinate is x, y, to write this in unit vector representation, you know what unit vector is. A unit vector is a vector whose magnitude is 1. The unit vector along direction x is this one. It is given by I, and the unit vector along y-axis is a vector whose magnitude 1 and its direction is on y-axis. It's denoted by j. So to write this in unit vector representation form, look this one. Look this triangle. This distance, it is x, and this y. Let's take this vector x, I. And let's take this vector. It is yj. This vector is yj. This vector is this xi. Therefore, our vector v, it's a resultant vector. It is the sum of xi and yj. Therefore, the x comma y can be written in this form. V is equal to this, the sum of these two vectors xi plus yj. So I can write this in unit vector in this form. AB is equal to x2 minus x1 in the I direction plus y2 minus y1 in the j direction. Okay, so the magnitude of this vector AB is denoted by this symbol and is given by this one. It is, if you take this vector, let's see it again. This is our vector x comma y. This distance, it is x, this distance y. The magnitude of our vector v is, it is this distance. Therefore, using Pythagoras theorem, the magnitude of v is equal to x squared plus y squared. Therefore, the magnitude of vector AB here is given by this form. It is the square root of I component plus the square root of j component or a y component. Therefore, this is how to evaluate, or it's a formula to calculate the magnitude of a vector. Now, next, if the coordinate of vector A is given, it is AB is a vector A. It's AB. This means it is A in the I plus B in the j. And in that of vector B is given to be it is EF, or this means this E in the I plus F in the j. Then the sum and the difference of these two vectors is given by this form. The sum of vector A and B is simply the sum of their components. Therefore, A plus B is equals to A plus E plus A plus E in the I direction plus B plus F in the j direction. If it is minus, A minus E in the I direction plus B minus F in the j direction. So, to add or subtract vectors, simply you add or subtract their components. And to multiply the vector by a scalar r, simply you multiply each component. So, RA means you multiply A and B by R. Okay. Now, let's see about dot products of two vectors or scalar product. What does this mean? Scalar product. By the way, dot product or scalar product means it is a product of two vectors which result in a scalar. For example, from your physics lesson, work is the dot product of force and displacement. This is the dot product. The product of two vectors giving us a scalar. So we call dot product or scalar, and we define this dot product in this form. It is defined by this form. The dot product of vectors A and B is defined as A dot B is equals to magnitude of vector A times magnitude of vector B cosine of theta, where theta is the angle between vector A and B. Now let's see this one. Let vector A given in this form, AX in the I direction plus AY in the J direction, and vector B is given as BX in the I plus BY in the J. Then the dot product of these two vectors can be also evaluated in this form. A dot B is equal to, it is the dot product of vector A is it is AX in the I plus AY in the J dot BX in the I plus BY in the J. let me ask you questions. Look this one, I dot I. What will be the value of I dot I? Okay, I dot I means it is given as it is magnitude of I times magnitude of I, cosine of the angle between I and I is 0. Therefore, it's 1 cos 0 is so 1. I dot I gives you 1. Not only I dot I, J dot J also gives you 1. This is same as J dot J. And look this one, I dot J. To find this, I dot J, this is equal to this magnitude of I times magnitude of J cosine of the angle between I and J. They are mutually perpendicular. They are perpendicular. So, it is 90 degree. Since cos 90 is 0, this product gives you 0. Therefore, I dot J and J dot I is equal to 0. So, using this concept, let's find A dot B. So, A dot B, this equals to AX I dot, it distribute over BXI plus BYJ plus AYJ dotted with BXI plus BYJ. Therefore, this is equal to the dot product of these two is AX BX times I dot I. I dot I is 1. Therefore, the dot product of the two is AX BX. The dot product of the two is AX BY times I dot J. I dot J is 0. Therefore, AXI dot this BYJ is 0. Okay, plus let's continue to the other part. Look this one, AYJ dotted with BXI, J dot I is 0. Therefore, this part will also be 0. The other part is says AYJ dotted with BYJ. So, this equal to AY BY times J dot J. J dot J is 1. So, 1 times AY BY is AY times BY. So, the dot product of two vectors can be also evaluated using this equation. So, the dot product will be given us in this form AX BX plus AY BY. So, to find the angle between the two vectors, we can use these two equations. A dot B, we have this one. A dot B is equal to magnitude of A, magnitude B, cos theta. So, to find cos theta, you divide by this both sides, you will have this one. So, cosine of theta is equal to this A dot B divided by magnitude of A, magnitude of B. And we can also put the value of A dot B by this one also. Okay, now let's continue. The unit vector in the direction of vector A. If you have a vector A, the unit vector along vector A is this one, and it is denoted by this symbol. The unit vector along direction A, it's denoted by this and is given by this equation. Simply you divide this vector by its magnitude. So, you get 1 without changing the direction. Therefore, the unit vector in the direction of A is given by vector A divided by magnitude of A. Okay, now let's continue. The dot product of I with J is 0, I with I, J with J, it gives you 1. If either of these, either U or V is 0, then the dot product will be 0. And dot product is also, it is commutative. U dot V and V dot U are equal. And if the vectors U and V are parallel, then their dot product will be either positive magnitude of U times magnitude of V or positive or negative. Let's see this one. If two vectors are parallel, their dot product is simply this u dot v. This is equal to this magnitude of u times magnitude of v cosine of theta. Parallel means either they form 0 degree, the angle between them will be 0 or 180. If it is 0, their dot product is positive 1, positive u, magnitude of u times magnitude of v. If the vectors are in opposite direction, cosine of 180 is minus 1, this becomes negative. Therefore, the dot product will be, if the vectors are parallel, plus or minus magnitude of u times magnitude of v. In particular, for any vector u, we have this is a basic property u dot u, u dot u, u dot u, u dot u is given by this form. It is magnitude of u times magnitude of u times the angle between u and u is this 0. Therefore, cos 0 is this 1. Here we have this 1. It is magnitude of u squared. Therefore, u dot u is given by this magnitude of u squared. So, if vectors u and v are perpendicular, if two vectors are perpendicular, then their dot product it is 0. These are a basic point. Now, let's continue. Example. Here, given vector A 2i minus 3j and the initial and terminal point of vector B, its initial point is given and terminal point is given. So, using this, we are asked different questions here. Let's start from A. Let's see each one by one. First, the given one, vector A is given, it is 2i minus 3j, and vector B, we need to find vector B. Its initial and terminal point is given. Therefore, vector B, this is equal to, it's simply the difference of their component, terminal minus initial. 3 minus 2, it is 1, comma, 2 minus negative 1 is 3. Therefore, vector B is this, when written in unit vector form representation, becomes I plus 3j. So, B is equal to I plus 3j. We have these two vectors. So, the first question is find 2a plus b. So, simply 2a plus b is equal to twice of vector A plus vector B. So, this is equal to twice of this 2 times, which is 4 in the I, 2 times 3 minus 6 in the j plus I plus 3j. And simplifying this, you will have this one, 4i and I, 5i minus 6j plus 3j gives you minus 3j. So, this is 2a plus b. Second question, we are asked to find the magnitude of 2a plus b. Since we have found 2a plus b, the magnitude of 2a plus b will be the square root of 5 squared plus negative 3 squared under square root. So, this is equal to this 25 plus 9, it gives you 34 units. So, the magnitude will be this, the square root of 34 units. Okay, C, we are asked to find the cosine of the angle between the vectors A and B. Since we have found, or vector A and B are given, vector A is this 2i minus 3j and vector B is this I plus 3j. So, we are asked to find the angle between them. To find the angle between them, we use this formula cos theta, cosine of the angle between the two vectors will be equal to this A dot B divided by magnitude of vector A times magnitude of vector B. So, we need magnitude of A is the square root of 2 squared plus minus 3 squared, it gives us square root of 13. And magnitude of vector b is equal to this, the square root of 1 squared plus 3 squared, it gives us square root of 30. And we need also a dot b. A dot b, we derive the formula for a dot b. It is a dot b, the product of the dot product of vector a and b given us ax bx plus ay by. So using this, their dot product is this, ax bx is 2 times coefficient 1, 2 times 1 plus ay by, ay is minus 3, by is 3, so minus 3 times 3, you get negative 9. So simply, since we have these numbers, you put on the formula, you can find the cosine of the angle between the vectors. So the cosine of the angle between the vectors will be this, a dot b is minus 7 over magnitude of a times magnitude of b, means it is a product of these two, radical 13 times radical 10. So it will be, it is cos theta will be this, negative 7 over the square root of 130. We are asked to find the cosine of the angle between the vectors, not the angle. If we are asked to determine the angle, theta will be equal to this cosine of cos inverse of negative 7 over the square root of 130. This is it. Okay, now the other part is dt's. We are asked to determine the unit vector in the direction of b. So the unit vector in the direction of b is given by this formula, b divided by magnitude of b. So vector b is here, it is I plus 3j divided by magnitude of b. We have found magnitude of b is square root of 10. This is a unit vector in the direction of b. Next question, we are asked to find twice of the magnitude of vector a in opposite direction. Let me say something here. If a vector is given here, if you multiply this vector by a certain constant, you magnify it, or you increase magnitude or decrease magnitude in same direction or in opposite direction. If you multiply this vector, assume this vector v, if you multiply it by a number or a constant number greater than 1, so the vector will be enlarged in the same direction. If you multiply this vector by negative number less than negative 1, the vector will be enlarged but in opposite direction. If you multiply this vector by the numbers between negative 1 and 1, for positive part it will be, the size will decrease, the magnitude of the vector will decrease in same direction. If you multiply by a negative number, the size will decrease and it will be in opposite direction. If you multiply it by 1, the magnitude will be itself. If you multiply it by negative 1, the magnitude of this vector will be itself but in opposite direction. So here we are asked to find twice of magnitude of vector a, twice of a, so you have to multiply it by 2 but in opposite direction, so you multiply it by negative 2. Therefore here we are asked to find minus 2a, so this equals to negative 2 times our vector a is, it is 2i minus 3j. Therefore the result will be this minus 4i plus 6j. So this is a vector which is twice of magnitude of vector a but in opposite direction. Next here we have this. Suppose we can use, by the way, bold letter to represent vectors. So suppose a and b are vectors with magnitude of vector a is given, it is 4, and magnitude of b is given 7, and the angle between vectors a and b is this pi over 0 or 60 degree. So we are asked to find the magnitude of 3a minus 2b and the cosine of the angle between 3a minus 2b and a. So to do this, we use this property. U dot U, we said earlier, is this magnitude of U square. So using this concept, we can solve this equation. The square of the magnitude of this vector is equal to the dot product of the vector 3a minus 2b dotted with 3a minus 2b. So using distributive property, 3a dotted with 3a minus 2b dotted with 3a minus 2b. And this is equal to 3 times 3 is 9, 9 times a dot a. We have a dot a here. It's a product of vectors. And 3a times or dotted with minus 2b equal to 6 times a dot b. Here also it is 6 times a dot b plus the product of the two, 4 times b dot b. So this is equal to 9 times a dot a is magnitude of a square. We say this one, u dot u magnitude of v squared. These two are identical, so add these two, minus 12. This a dot b means magnitude of a, magnitude of b, cos theta, cos the angle between a and b is it is pi over 3, plus 4 times b dot b is this magnitude of b squared. So this is equal to 9 times magnitude of a is given, it is 4, 4 squared, minus 12, magnitude is 4, magnitude of b is 7, cosine of 60 degree, it is 1 over 2, magnitude of b squared is this 7 squared. So you will have this result when you just compute this, you get 172. And since this 172 is this the square of the magnitude of 3a minus 2b. So we are asked to find the magnitude of 3a minus 2b. So you put both sides under square root, or the square root of this one gives you the magnitude of 3a minus 2b. The magnitude of 3a minus 2b is equal to the square root of 172. So this is equal to this, to the square root of 43. The next one, we are asked to find the angle between 3a minus 2b and a. To find the angle between two vectors, the formula is simple. It is the angle between two vectors a and b will be given by it is a dot b divided by magnitude of a, magnitude of b. So to find the angle between these two vectors, cos theta is equals to the dot product of the two divided by magnitude of this times magnitude of a. So this will be this cos theta is equal to the dot product of the two vectors divided by magnitude of 3a minus 2b times magnitude of a. This equal to, using distributive property, 3a dot a, 3a dot a, and minus 2b dot b is gives you minus 2 times a dot b, divided by, we have found this one, the magnitude of 3a minus 2b is 2 root 43, and magnitude of a is given, it is 4. Therefore, this will be equal to 3 times a dot a is magnitude of a square. This is 4 square, magnitude of a is 4, minus twice of a dot b means this magnitude of a, magnitude of b, cos theta. Magnitude of a 4, magnitude of b 7, cosine of theta is this pi over 3, it is cos pi over 3 is 1 over 2, divided by 8 root 43. Therefore, this when you compute this one, you get 5 root 43 over 86. This is the cosine of the angle between the vectors. It's a cosine of the angle between the vectors. So this is it. To summarize what we have seen today, the first one is the dot product. The dot product of two vectors is given by magnitude of a, magnitude of b, cos theta, where theta is the angle between the two vectors. And if a vector A is given in this form, in unit vector form, and b also given a unit vector form, so the dot product of the two vectors is given by the sum of the product of their coordinates, ax bx plus ay by. In addition to this, to find the angle between two vectors, you use this formula. Cos theta is equal to find the angle between vector A and b, you use this formula. Cos theta is equals to a dot b divided by magnitude of A times magnitude of B. And to find the unit vector in the direction of vector A, it's denoted by this symbol and it's given by this formula. So this is all about today's lesson, and I'll give exercise. Please try these questions, and not only that, to know more you have to read a lot. So read the notes and examples on your textbook from page 295 to 305, and do exercise 8.4, which is found on page 310. So I'll give you 1 minute to copy the question. I'll see you on the next lecture class. Until then, goodbye.